Hi, with this video I want to review some of the basic ways of getting summary statistics in R. Here we have a variable called y. There are 10 observations in y. Let's get, for example, the sample mean. That's accomplished by simply typing mean and giving as the argument y here. 49.2 would be y bar, the mean of the 10 observations. If I want the variance, the sample variance, I would use the var function, var y, and there we find it to be 539.51. If you get your calculator out and get the square root of that, you would find the sample standard deviation, or you can get it directly by using the SD function, sdy, and there we find it. Another popular measure is the median, and indeed there is a function called median, and if I apply it, we find the median of these data to be 43.5. Now the median is actually the 50th percentile. We can get various percentiles using the Quantile function. So if I were to type Quantile using y data, and I'm going to look for the 50th percentile, I should find the same median value. Indeed we do. A couple popular other quantiles are the 25th and 75th percentiles. They are called the first and third quartiles respectively. Let's get those guys. Quantile on the y, and I'm going to put 0.25, and this gives me the first quartile. If I want the third quartile or the 75th percentile, quantile y comma 0.75, and there we go, 60.5 is the third quartile. Now we can get a lot of these numbers in one shot using the summary function, summary on the variable y, and there we find R is reporting the min we find to be 22, the max 89, and the values that we found above. The first quartile of 35.25, there we see it right here. The third quartile of 60.5, there it is. The mean of 49.2, there it is. And the median of 43.5 here or here. The min, first quartile, median, third quartile, and max are sometimes referred to as the 5-number summary statistics. And indeed, they're used in the construction of the popular box plot. There's a function in R called the 5num, and let's invoke it, 5num on y. And there we see the values of 22 as the min and 89 as the max. They're consistent. The median of 43.5, 43.5. However, we're seeing that the presumably first quartile that we should be getting from 5num is different than what was reported above. And the third quartile, 60.5 versus 65.0, is indeed different. What's going on here? Part of the issue is that the computation of quantiles, there's no universally accepted formula. Indeed, you'll find in different textbooks, different software, all sort of beat to a different drum in terms of what formula they might use. And we see here, even within R, it's computing these quantiles differently. Let me show you the formula that is behind the scenes with R. To do that, we first have to sort the data. Let me define a variable called y order, and that will be using the sort function. So sort on y, and if I type y order, there are the data in order from smallest to largest. Now what R does is compute a position for the quantile of interest. All software actually in some sense do that. The question is how that position is computed. The way R computes it, and I believe the way actually Excel also computes it, but not the way Jump or Minitab, two other statistical software, compute it, is by using the following formula. And let me just type it at the prompt. You type 1 plus, then you type in the percentile that you're seeking. In this case, the 25th percentile, so I'll type 0.25 times the sample size minus 1. The sample size here is 10 minus 1. Close it out, and let's see what we get. We get 3.25. So that's saying that the first quartile is 3.25 deep into the data. If we look above here at the sorted data, this is the first one, this is the second one, this is the third one, and here's the fourth one. So 3.25 positionally is in between the third and fourth observation of the sorted data. 33 is in the third position, so we know that it's at 33 plus a bit extra, namely 0.25 into this gap between 33 and 42. Now the gap is 9 wide, so if we were to take 0.25 of that 9 wide gap and add it on top of the 33, there we go. We find 35.25 is the computed first quartile, which matches up with how the quantile function computed it right here, how the summary function reports it. So how does the 5num come up with 33? Well, here's how. And let me just note it verbally, and then I'll show you by typing in stuff in R. Basically, the idea is using another method for figuring out the first quartile, and you could just similarly, by symmetric arguments, talk about how you would get the 75th percentile or third quartile. What you do is you divide the data in half. The median is the 50th percentile, so the lower half of the data set of the sorted data is really from the 0 to the 50th percentile. The upper half of the data is from the 50th to the 100th percentile, the largest value. If you think about just the lower half data from 0 to 50 and take the median of the lower half, well, where's the median from 0 to 50? We're smack in the middle from 0 to 50. It's 25. So the idea here is to find the median of the splitting the original data in half, the lower half data, and then taking the median of the upper half data would give you the 75th percentile. Let me define a variable here called y lower. It's just going to take the lower half of the data. Now the lower half of the data, since there's 10 observations here and the median is in between 43 and 44, would be the first 5 numbers. So I'm going to define y lower to be the y order data, and I'm now going to type a left bracket, not a left parentheses, 1:5 right bracket. That tells R just pick up the first 5 observations in the sorted data. Let's type out y lower. And then you can see the y lower numbers are 22, 23, 33, 42, 43. Indeed, those are those first 5 observations there. The median, well, we have an odd number of observations. The median is right smack in the middle, 33. Let's look back up at the 5num. That's indeed what it's reporting. Let me do as a confirmation. If I type median on y lower, you get 33. And that's how the first quartile is computed with the 5num. So R is really calculating the first quartile and the third quartile differently with these two different functions. Okay, hopefully this has been helpful, and we will talk next time.